Morning.
Good morning, Paul. Long time no see,
Yeah,
right?
right. We have to stop meeting like this.
I know.
Hi, Sandy.
Leslie, I'm going to make you a co-host if you want to help sign people in while I'm introducing everybody. I think it's going to be another big crowd today, so that's good.
I don't know if you saw my email about the Williams room that we meet in.
Yes, I did.
Yeah,
I did.
Quite a small world.
Isn't it?
Yeah.
Yeah, no, I did. I sent a response. Maybe it went to Jennifer, not you or something. I'll have to check.
I've been out food shopping, so I didn't see it.
Yeah, I think it was nice of you to recognize the family. It's always important to, appreciate people for what they do. And it is great to have that French wing in the Williams room as, a little nonprofit to be able to be incorporated with other groups. And
French is another, I think, relative of Mary Lou and Wally Williams, because there's an easement in Atkinson on the French land, which I think is contiguous with everything that they saved and donated.
Yeah. Yeah, I think there might be a couple French family properties out there. So I'm trying to stay cool. It's pretty hot here.
I know. Crazy. Don't get too used to it.
I guess next week.
I just got my dog his first swim of the year.
Wow.
Yeah. That's pretty nice.
Yeah. So Leslie, I made you co-host. So if you want to keep an eye on admitting people.
Yep.
That'd be awesome. I mean, I can do it until we start, but once I try to introduce people, it might. It's always helpful to have another person looking at the
Yeah, I don't have anybody coming up at this point.
Nope, right. I don't either. So.
Okay, good.
And I can usually keep up with it until I start to talk, and then I'll notice there'll be like 3 people in the waiting room or something. So.
I'll keep watching.
Thank you. So this is the last of our Zoom for wetlands training. We're going to be in person after this. So that's exciting. For me anyway.
It is.
Maybe not for everybody who has to travel, but I think it'll be good.
Oops.
All right, somebody's asking for the link, so I'm gonna just check my email real quick. All right, so I just heard from Rick. He's signing in shortly too.
Hi, Barbara. Thanks.
Hey, Rick, sure. It's funny. When I got that text, I was like, I need to put your name next to your number because I was like, wait, I'm not sure
Who is this guy?
I know.
What do you mean? Oh, yeah. Like one of your presenters. Lame.
Well, I'm glad you got it. So that would be a lot of stalling on my part. It'd be like,
Yeah, well, let's see. Okay, Barbara, take it away.
I know.
Wetland functions.
yeah. So anybody been gardening lately? Yeah.
Oh, yes.
Yeah. I know. It's crazy. I have this little patch of bloodroot out in my,
Oh, nice.
and I'm trying to like make room for it, keep all the other stuff away.
Well, the snow just finally melted off the yard today.
Wow.
But we still have snowbank piles, from the
Yeah.
plowing, but yeah, it's a hopeful scene out there today.
Sure is. It's crazy.
Uh,
Well, my daughter's going to try to ski Tuckermans this weekend. So we'll see if there's how much of this warm weather,
yeah.
what it did to the conditions. We'll see.
Yeah, it should. Yeah, warm weather firms it up pretty good.
Yeah. Might be
you know,
okay.
It prevents avalanches as long as it doesn't there's any kind of heavy snow. You're good,
Yeah. Should be okay, I guess. I've never skied it. Frank has, but I haven't. So. All
It's
right.
one of those New Hampshire traditions. How are you, Sandy?
Doing well, Rick. Thanks. How are you doing?
Good, good. Beautiful day out there.
It is.
Sure
Wow.
is.
Wood frogs came right running in last night.
Oh,
Boy.
yeah.
Yeah.
Did you have any rain?
No, they just come
They
in
just
when it's warm.
moved.
Yeah, they
Okay.
move. They don't care. They're not as like
Well, that it
particular
seems like the
salamanders.
male wood frogs are here, had arrived, but the females had not arrived.
Oh, they were hot and heavy this morning.
Oh, I'll have to check them out. But they were just, in fact, I think the males kind of stopped calling because the females hadn't shown up.
Hmm.
Yeah, like why put on your best suit and dance if there's nowhere to
It's
do
okay there. Yeah.
it? Yeah.
Well, it's almost that time.
It is. Is Marianne with us?
I have not seen Marianne show up yet.
Okay.
Thanks to all who signed in a little early. It makes it easier on us to get the program going. So I'll just wait one more minute.
Sure.
Wait and see if Marianne, maybe I'll check my email. Hopefully she has. I saw her name on the list, so she should have gotten the link. Okay.
Well, just in case I've got her PDF, so we can always throw that up.
Okay.
Yeah.
All right. Well, it is noon, so I'm going to go ahead and get started so we can keep everybody on schedule. We've got a lot to cover today. So hello, everybody. I'm Barbara Richter, the Executive Director at the New Hampshire Association of Conservation Commissions. And for those of you who don't know us, hopefully you all do by now, but we're a nonprofit organization working to support conservation commissions so that they can protect the natural resources in their local communities. We provide education and assistance and advocacy for 217 conservation commissions here in New Hampshire. And just very quickly before we get started, I have a few reminders. This program is being recorded, and I will be sending a link later this afternoon to everybody who registered for the program. Eventually, this will go up on our YouTube channel, which you can get to through our website, and I'll also be sending those links. All the previous programs are also now on our YouTube channel, so if you missed any of the other wetland training Zoom meetings, definitely go on our YouTube channel and take a look at those. Because we're encouraging everybody to participate in all of these programs so that when we get to the field study and the in-person classroom, that we have a really good sound foundation for the work that we're doing. So we are going to ask that you invite you to ask questions, but we're going to ask you to use the chat box at the bottom of your screen. Again, it looks like another large group, so it's helpful to put those questions in the chat box, and we'll go through them as maybe for each presenter, we'll stop and ask some questions at the end of each presenter. So today's program is the Introduction to Wetlands Assessment, the Classroom Foundation. And we have Rick Vanderpool, Sandy Crystal, and Marianne Tilton here today to help us walk through all this. And this program is really designed to prepare you for the field study training that's going to be held on May 19th. It's going to outline the classroom learning and focus on water quality, ecological integrity, and wildlife values provided by wetlands. So the wetlands assessments, functions, and values. We'll also touch on the various methods of wetland identification and how to collect data prior to your site visit. And then we'll wrap up with some preliminary review of the maps for the May 19th field site. So we created this program to really help conservation commissions better evaluate their water resources and develop a proactive program for protection. This was one area where I have a question, and I know that it's definitely helpful to commissions to have the background wetland permit review. So we're happy to have Rick Vanderpool, Sandy, and Marianne Tilton here today. I'd like to introduce Rick first. He is the principal of Ecosystem Management Consultants out of Sandwich, New Hampshire, and he's been a certified wetland scientist since 1998. His company has conducted wetland delineations and wetland assessments in more than 128 New Hampshire towns. And he's taught various wetland courses at Antioch, New England Graduate School and Plymouth State University. We also have Sandy Crystal, who's a professional wetland scientist and a Bow Conservation Commission member. Sandy retired from New Hampshire DES after 23 years serving on the Wetlands and Watershed Management Bureau. And she also worked in Drinking Water and Groundwater Bureau, coordinating the Source Water Protection Land Conservation Program. She serves on 2 town boards, the Planning Board, and she's chair of the Bow Conservation Commission. And we also have Marianne Tilton here today from New Hampshire Department of Environmental Services. Marianne serves as the Assistant Wetland Bureau Administrator and has worked on compliance, permitting, and program development. She's been with the Wetlands Bureau for more than 30 years, so it's great to have her and all her expertise. She is a Master's of Science from URI, a BA from Connecticut College, and a JD from UNH Law School. She's also a professional wetland scientist and certified wetland scientist. So at this time, though, I'd like to turn it over to Rick to get us started. And again, just a reminder to mute so we can all hear the programs. Thanks, Rick.
Okay, great. Thanks very much for the introduction, Barbara. Nice to see some familiar names with us today. Some of you are old timers, and perhaps some of you are just getting into wetland science, and hopefully more than a few of you have seen one or more of the previous seminars. We'll build off of some of what we've already talked about, that is to say the definition of wetlands and the 3 criteria that make a wetland a wetland. We'll talk more about how wetlands are defined and how we take an approach to assessing or evaluating them for a variety of purposes. I'm going to start off with an overview of functions and values, or functions as we're now calling them, services, mostly what we used to call ecosystem services, now wetland services for society. And I'll cover 4 of the more common methods that are used, not all of the methods that are used out there in the United States, but more of the 4 of the more common ones. I'll finish actually with one that talks about the New England region relative to the Army Corps method that's still being developed, and that which many of you, I know, on this Zoom session attended the training workshop. Mark Jacobs, Mark West, both of whom will be with us on the field session on May 19th. So without further ado, I'll go ahead and share my screen, and we'll get started. All right, so again, this is an introduction. Consider that many of us have taught wetland assessment methods at the undergraduate or graduate level or in all-day seminars. So we'll kind of hit the highlights pretty quickly today. And my apologies in advance if you haven't had that second cup of coffee and you're not traveling as fast as I am over this material, but we'll hopefully get the highlights. And again, the field session is really, it's one of my favorite ways to introduce folks to it. So you'll have that chance on May 19th to really take a hard look at some of the indicators of these wetland functions. The definition of wetlands, which we've shown you many times now, actually help us cue into what we're looking at and what we're looking for. Okay, are the waters that make up the wetlands still there? Are they still in good shape? Right? Are there inputs from outside of the wetland itself in the buffer areas, or maybe even in the watershed, that are affecting the wetlands? Right? Are the plant communities that are normally associated with a particular wetland unit intact? Have they been overrun by invasive species? All of the things that contribute to what a wetland is, of course, is on the line for assessment, right? So these are the things that we're going to be looking at as we go forward. We have, of course, talked about identification and mapping in this sort of suite of what's involved with wetland science. We've talked about classification. We also talked a little bit about the conservation and regulatory side of things in the 4th session. And now we're talking about functions and values. The Army Corps had, in this last training that they did for their regional method, had what I thought a nice summary slide relative to what we think about as we consider assessing the wetlands. And of course, it's a bit of Army Corps speak, so bear with it, but this is how the sort of flow chart was structured for how they started investigating what's out there and what needs to be out there in terms of wetland assessment techniques. And some of these, like the considerations, are certainly ones that you as town conservation commissioners want to consider. Are you going to do the whole town? Are you looking just at certain wetlands? Are you looking at certain wetland types? What's the context? Are you doing it to protect wetlands? Are you doing it to protect particular functions that are associated with wetlands, like wildlife habitat or something like that? Can you document all the existing conditions? As you know, we have a bit of a restriction as conservation commissioners relative to on-site evaluations. So how much can we get from our off-site data sources, like we learned in the 3rd session with Stephanie, right? Looking at all these remote GIS sources that give us information for us to do our assessment. And then, of course, there's a lot of input to what the assessment models are, not just the plant communities, the hydrology, but some of the specific site attributes, for example. Certainly some of the physical and biophysical or geological attributes of a wetland factor into whether or not the wetland is functioning as it should, in what we call a reference condition, right? That reference condition think, pre-European settlement, and perhaps even pre-Aboriginal sediment in certain areas where the functionality is undisturbed by artificial or human means, right? So that's a reference condition. So that's what we're in some ways trying to compare. And when we look at that, the structure of how we go about that looks also at how much of a difference it is, how much it has varied from that reference condition. Is it really similar, the similarity index, or is it very different than what we would call a reference condition? So some of those, basic attributes are being considered as we go about the task of doing our evaluation. And then, of course, in the analysis, this will vary by the method. Again, we'll talk about 4 different methods, but this, what type of analysis depends on the method. Many of them have the same functions that we're looking at, but many of them have very different ways of going about it. Some are quantitative, and some of them derive actually individual metric scores, which is one of the targets of the Army Corps method. You'll have a lot of metrics you'll be dealing with, and those are just numbers that mean something, right? The metrics that help us track how a wetland is doing. Some have composite scores for certain metrics and others don't. One of the first methods we'll talk about is largely qualitative. There's no real number that is derived from any of those functional assessment questions that we ask. So in any case, it gives a good framework for what we're dealing with. So here are the 4 methods that we're going to talk about. I'll start with the Federal Highways method, jump into the New Hampshire method, talk a little bit about the ecological integrity assessment method. That's number 3. And then we'll talk about the pending, I should say, pending Army Corps method, which many of us were trained up on again in the last month or so. So first and foremost, the Federal Highways method. This was derived, as it says, in conjunction with the Army Corps Delineation Manual in 1987. And then there was a memorandum of agreement that had to do with sequencing relative to how wetlands are treated. For example, we've talked about, first and foremost, you avoid it if you can. Then if you can't avoid it, you minimize your impacts. And if you can't minimize your impacts, you compensate for the loss of the impacts, which equals compensation for the loss of function. So here is right away a really good way to identify how you have impacted a function by doing an assessment method. And that's what the FHWA approach used. This is one that incorporates many of the familiar wetland functions that we've seen before. And we'll go over some of these in more detail when I get to the New Hampshire method. But you can see each of them have sort of a symbol that is assigned. And I'm not going to go through every single one here, but each symbol is something that actually then gets defined and identified when you're doing your method, your actual evaluation. If you look at something like groundwater recharge discharge, this is something that we've seen before. This is just an example of one of the many functions that they list in the Federal Highway method. And it's something that is critical to not just the quality of the water in the wetland, but also the quantity of the water. Has that any kind of input, water input, been disrupted? Is there a dam upstream? Is there a lot of impervious soil or impervious surfaces rather in the watershed above the wetland? So all of those things are, relate to the quality and the amount of water that's present. When the method is finalized using mostly remote sources, but certainly some on-site reviews for particular projects, then you end up with looking at the various different alternatives. And that's how this was initially designed, thinking highway now. The last one that I worked on was the north-south road in North Conway. And this was, you know, some rather major impacts, and therefore a NEPA based review of the impacts was required, and the federal highway method was employed, and it looked at all the alternatives relative to each of those functions. So in this chart on the lower left, you see, for example, alternative 9 had various primary and various secondary functions, whereas the modified alternative 9, which this LEDPA, or what we familiarly call LEDPA, is the least environmentally damaging practicable alternative. There's a great federal acronym for you. This, if you learn nothing else, learn LEDPA. Right? And so that, in this particular case, the modified alternative 9 was in fact the least environmentally damaging practicable, that means, you know, financially doable alternative. And this is how this method was employed to help compare the different approaches to a particular project to come up with that LEDPA alternative. Again, using an analysis of each of those functions that I listed. The federal highway method also, and this is sort of the second to last slide here, allows you to comment on each of the functions that are present in a particular wetland. And is it present, the function, is it present or absent? And then are various attributes to those functions that demonstrate whether they're present or absent. And in this case, they utilize an appendix which has this laundry list of criteria, which gives you that yes or no answer to whether or not a particular function is present and whether or not it is a primary function or a secondary one. In this particular case, you can see the 4 highway alternatives, and at each of these wetlands, there's this little box which you fill out and you plunk in those symbols for the functions that are present. So on a very quick visual basis, you can look at this map, and this is of course drastically reduced in size, but you look at this map and you can see which wetlands are really functioning for the various you know, attributes that you're evaluating. So in summary, this is a largely qualitative approach. It's mostly used for as an alternatives analysis, but is also applicable for very large projects where you're doing functional analysis because you're required to do so as a part of the regulatory permitting process, right? The permits require, for example, mitigation of functions if you impact a certain amount, and we have those amounts pretty tightly drilled into our regulations, both the state level and the federal level. It's a quick and easy way to show this least environmentally damaging practical alternative. You identify primary and secondary functions, and you can relate that to the mitigation MOA, memorandum of agreements, relative to how you're going to tackle that process of providing the least impacts possible. So it's a fairly, you know, relatively easy method to use. It may not seem so if you've never seen it before, but for those of us who do a number of analyses, this is sort of the go-to method, and hence it's cited in our regulations. Okay, New Hampshire method. And by the way, just Sandy and Marianne, I won't take the entire hour. I promise you. I will go probably till about 25 or 27 after, if I'm doing well. Here's the New Hampshire method, which has sort of what I call the big 3 ecosystem services of wetlands: the water quality service, the water quantity service, and the wildlife service. And within that, there's a few different functions that are called out that contribute to these what I call the big 3. Then there's 3 more functions that what I call the social functions, and these are largely the more qualitative and subjective ones in the New Hampshire method, called scenic quality, educational potential, and water-based, or wetland-based rather, recreation. So there's the list of 10, And we go through each one of those using data forms that ask you questions about what's on the landscape. In the appendix of the New Hampshire method, there is a guidance section on how you answer the different questions, some of which you can get in the office from remote data sources, and others you have to get on the ground or at least nearby in the field. And that nearby part gets a little tricky if you're dealing with a lot of wetland, a large wetland that has many landowners. And of course, you may only have permission to access, written permission now, access a portion of the wetland. So hopefully you can choose wisely as to the points of observation that you have or that you can get into in order to fill out the rest of the data forms. So ecological integrity is our first one. It deals with how much impacts there have been on the landscape surrounding the wetland and particularly in the watershed above it, right? And some wetlands obviously are very pristine. Others have been heavily impacted by, in this case, a gravel operation. There's a few other questions that deal with the buffer zone, which in the New Hampshire method treats it a 500-foot horizontal distance away from the edge of the wet as the buffer zone, wherein which you determine how many impacts there have been. Wetland wildlife, of course, is pretty straightforward. There are a number of questions that ask you about habitat types. You read the National Wetland Inventory or NWI maps to see how many different cover types there are out there. That has a factor. You look at waterways, particularly in terms of how those surface waters are being used and if they're very large. And that, of course, relates to fish and aquatic life habitat, which you may not end up evaluating at all if there are no surface waters present in your wetland. And we have a lot of those forested swamps, for example, that lack appreciable surface water to where this question is not even addressed. What's the fish and aquatic life habitat like? Scenic quality, as I mentioned, is one of the sort of more subjective attributes that you're evaluating, and has a lot to do with, how much you can see, what you're looking at, how dramatic the landscape is, and that type of thing. Can you get on site and do research? Are there active research plots or monitoring sites being utilized in this wetland? Can a school group visit this wetland? Is there good parking? Can you get a school bus nearby? That's some of the stuff that we deal with the educational potential. And the same, very much the same with wetland-based recreation. How accessible is it? What types of wetland recreation is going on? And can groups of individuals utilize that property or that wetland for these purposes? Flood storage sort of goes without saying. It's disputably, but likely the most economically important ecosystem service that wetlands serve. And therefore, we spend a fair amount of time in the 2011 rewrite of the method to make sure that we had this one drilled in. And this one, again, is not unlike the other functions, has its own numerical score that results from the answers to the questions that it offers. Groundwater, like I mentioned, under the Army or the Federal Highways method, this is an important function as well, and it largely deals with whether or not there is a stratified drift aquifer at the site. Are there porous sandy soils that will allow for precipitation and runoff to filter into that aquifer? And is it being used in a public water well way? Sediment trapping and nutrient attenuation, both of these are sort of the water quality functions and ask about what the wetland does relative to receiving potential inputs like floodwater, siltation, and so forth. And you can see in this one example how this wetland is serving that purpose quite well. And then nutrient attenuation, how well is the wetland uptaking nutrients that are being run off from the surrounding landscape? Is it channelized and there's no nutrient uptake, or is it a seepage slope where, yeah, all of these nutrients that are being deposited are able to be transformed by the plant and decomposition materials in the soil. Shoreline anchoring deals with how wide and how vegetated a shoreline is in the event of wave action. How well is that fringe wetland, in this case, operating in terms of protecting a shoreline and preventing this type of siltation to our streams and rivers downstream. And then last but not least is a noteworthiness function that addresses some of the unique attributes of wetlands like rare and endangered species, wildlife action plan, tier 1, 2, and 3 highest and best habitat types, that kind of thing that doesn't get picked up in the other 11 functions. So in sum, it's quantitative, it's not additive, you don't get a single wetland score, and yet it's, you know, fairly well science-based in that you have to observe discernible data and report that as an answer to a question. And those questions give you point values which you add up for the function alone. And so you can compare in that way how different wetlands are operating relative to certain functions. Gee, I want to protect all the best wildlife habitat wetlands in my town. You can just use the wetland wildlife habitat function and use that on the wetlands to determine how well each of those wetlands are doing for that particular function. So that's another potential use of the New Hampshire method. All right, I am going to go through this pretty quickly. I want to make sure Sandy has plenty of time. The ecological integrity assessment method basically deals with ecological integrity, looking at different levels of review of the wetlands, and it's pretty much dealing with just one function, right? Ecological integrity. It is metric-based, it's quantitative, and it's pretty intensive. You can get a lot of the data remotely, but it does help, and you do have a field data form to fill out for particular aspects of the plant communities and the plant structure at the site. And that's pretty much all I'm going to say about it. It was developed by NatureServe. One of our Eastern regional authors, Bill Nichols, works at our Natural Heritage program, and he's done a great job in providing a system-wide assessment of these characteristics of ecological integrity. And you can get some of that data directly online from the Natural Heritage website. And then I'm going to skip over the rest of this and jump to the Army Corps wetland functional assessment, which again is just in final review. I think Paul and Erica, they resisted from saying, oh yeah, it's going to be out in 6 months, which of course you look at the date here, that was 2017 when they did, I think, round 3 or 4 of this. We're not sure when it's going to come out, but when it does, believe me, it's had a lot of great review, a lot of great input, and it will be sort of the go-to method for higher end, more complicated projects that require functional assessments. So this is coming for a lot of us wetland scientists. Their goal was to produce a functional assessment method that was quantitative, okay? And they're assessing 3 different categories of functions, a total of 14. And I'm going to jump right to that so that you can see what we're dealing with. Some of the same things we've been talking about. Sediment, instead of sediment, they call particulate retention. Removal and sequestration of heavy metals, which they elevated to its own function because it's so significant. Phosphorus retention, which of course, along with nitrogen, is critical for water quality services that our wetlands provide. Also in hydrology, you have groundwater recharge, surface water, stream flow maintenance, these things that contribute to the hydrologic aspect of the wetland. And then last but not least, a bunch of 3 specific functions dealing with the biota or the wildlife. So they too sort of grouped their functions into 3 buckets. They have in this last one, one that is has several different specific metrics that you derive in order to come up with each of a score for each one of these. And that's where it does get a little bit tricky. And I can say this is not for the faint of heart, at least from what I've seen. You really do need to have a professional or certified wetland scientist running these assessment tools, since they are going to be fairly rigorous in their review of each of the functions. And so just as a last slide, I'll mention that we have I have this comparison slide, which you'll be able to review more closely online after we get done with this seminar. And, just it summarizes what the major functions are, how many there are, how many sub-functions there are, what's the suitability for some of the applications. And you'll see that the level of effort definitely does differ from federal highways being the easiest, lowest level, New Hampshire method EIA is a medium effort level, and then of course the EIA and the ACU or Army Corps method being a very intense and high level of effort required to complete. So that's just give you a sense of what's out there, what those of us are doing. And when you ask us as a town to do wetland functional assessments, this is, you might have this as a backgrounder to understand what might make sense for your town in completing these assessments. All right, that's great. Some of these, we've repeated this slide. I'll just stop now and we can go back to Barbara. Actually, I guess you can, we can move along and bring up Sandy.
Great.
So,
Well,
thank you.
thanks, Rick. You did a great job of just the overview, because there was definitely a lot of information there. And keep in mind, we're not asking people to be certified wetland scientists, but it's important to know how the certified wetland scientists do the work that they do. So,
All right.
Sandy, we'd like to move on. And are you going to bring up the slides and we'll talk a little bit more?
Yes, I'm getting to that
Great.
point right
So
now.
can you just tell me what the agenda is? I thought I was next. So is it, am I last, or how is that going to work?
I do think you're last. I thought you were gonna follow up with some
Okay,
of
the last outline I got from Rick had me next, so
Oh,
I'll
sorry. Okay.
just make sure I know where I fit.
Okay.
Right. Okay.
Sorry about that. Thanks, Sandy.
Okie dokie. All right, great. Yeah, thank you, Rick, for putting out all that information. There'll be a little bit of overlap, which will be good for folks. We'll go from there. Okay, Rick gave the introduction to wetland functional assessments. I'm going to talk about just where in the rules it's required, talk about functions and values, which, as Rick noted, values are now being called services, like ecosystem services. I'm going to talk about ecological integrity, water quality. Actually, there's some quantity thrown in as well. And wildlife, and then some additional resources. So wetland functional assessment in the wetlands rules applies to minor or major projects impacting here. It talks about the non-tidal wetlands, but then there's assessment that's required for the tidal areas as well. And this is the supplement that has all those icons that were on the front cover and a title slide, and then we'll go through a little bit further. You can use an alternative scientifically supported method, and that's described in the rules. This is a list of the functions and values. It's what's in the core highway methodology supplement. And then there's ecological integrity added because ecological integrity is in the wetlands law. I'm going to focus on the ones that are in blue, or the kind of the water quality related. I didn't select shoreline anchoring, but that is actually part of the water quality group as well. And then the purple ones are related to wildlife, or can be related to wildlife with the production export. So in terms of ecological integrity for a an area, wetland or otherwise, to have ecological integrity. An ecosystem should be relatively unimpaired and across a range of ecological attributes and spatial and temporal scales. And this is from the Natural Heritage Bureau and NatureServe EIA ecological integrity assessment work. The DES rules mention that ecological integrity is the health of a wetland or other aquatic ecosystem because it's focused on the wetland rules. So when we assess the ecological integrity of a wetland, we're assessing wetland condition. So, and it's important to assess wetland condition because that gives you an idea on how well the wetland is performing the functions, or the wetland components are performing the functions. At the bottom, and it is kind of a wetland health type of thing. At the bottom right, that kind of teardrop icon is from the EPA National Wetland Condition Assessment. They do these surveys, National Aquatic Resource Surveys, on a 5-year rotation. And so every 5 years since 2011, they've done these National Wetland Condition Assessments, which is a very intensive effort at sampling wetlands across the nation. We're only dealing with New Hampshire, but we have sampled wetlands under the National Wetland Condition Assessment. So when you look at ecological integrity, there's a landscape context, there's buffer, excuse me, a buffer on the wetland resources, what vegetation is present, the soils, and the hydrology. So when you look at landscape, with ecological integrity, you tend to look at identifying stressors. So what things in the landscape are degrading that wetland or that habitat. So you have stressors, any type of development, disturbance such as athletic fields or lawns, roads, agriculture, livestock, utility corridors, and even recreational use. And all these things are things that kind of we create in the natural environment. I will, let's see. So we'll look at vegetation, look at stressors like logging or mowing. Actually, if there's excessive animal herbivory or insect damage, that can significantly affect the ecological integrity of a wetland. The presence of both non-native plant species, and then there are aggressive native plant species. There are some wetlands like cattail marshes that are cattail marshes naturally. And then there's some areas where cattails will grow very thickly because there's an influx of nutrients. So that's cattails are one of those that kind of can exist in both situations. Ecological integrity looks at the soil. So is there disturbance to the soil? Is there sedimentation, erosion, rutting, compaction, grading? And you can see in these settings, there's the photos show various impacts. The top right is logging, and that's actually a rut in an upland area. You can see that in the left slide, the disturbance right next to a purple loosestrife meadow. Hydrology is a major component, as you likely can understand, because it's hydrology that makes our wetlands, that creates our wetlands. Because if we don't have the water there, we're not going to have the hydric soils, and we're not going to have the plants there. So we look at disturbances to the hydrology by looking at stressors, presence of ditches, culverts, engineered channels, a dam, is there point source discharge, urban runoff, farm drainage. The top right picture is on the site that we'll see next month. For those of you that are able to attend. The bottom right is on the Granite View mapper, and you can choose, and actually I think it's on the wetland permit planning tool as well, to select for dams that are present. And so what's circled in red there is a dam that's shown. And up in the upper left, that's a wetland that was kind of temporarily drained while a dam on the adjacent lake was repaired. So you can see all these impacts from changes in hydrology. Whoops, here we go. So for ecological integrity, some of the data sources, I've listed some. There's really more as we go through some of the other functions. Some of that mapper data is also appropriate to ecological integrity. But really, the mapper is great for identifying land use, alterations to the wetland with road crossings, logging. You've looked at aerial imagery and you can see logging that's been done. Checking for an intact buffer or any impervious surfaces in the buffer. The aquatic restoration mapper has some great information about the culverts that have been assessed and to what extent they impact aquatic organism passage or passage of flood flows. And then I mentioned dams. When you get to the field, with all of these functions, you really want to confirm the map data to the extent that you can get to the areas you're assessing, the wetland system. Invasive plant species are important to confirm in the field, and identifying other features that are not visible from an aerial image. One of the sites we noted that we came across, you can have a pond that looks like it has a nice buffer around it, but on the ground there could be some a drainage pipe that's diverting stormwater runoff right into it, and often on the aerial imagery you wouldn't be able to see that. So wetlands are, as Rick described, play an exceptional role in water quality improvement, toxics retention, removing nutrients and transforming them. They retain particulates, anything that's kind of floating around. They sequester heavy metals. They transform nitrogen, so they remove nitrogen and send it back into the atmosphere as a gas, and they perform carbon sequestration, which is more important as we're dealing with climate impacts. I do want to say on the sequestration of heavy metals, in some of the research that I came across recently, apparently while plants sequester heavy metals, it doesn't mean that they cannot get into the food chain by organisms that might eat those plants. So that was something that was interesting to come across. So wetlands are very important for moderating flood flows. We've always used the analogy of them acting like a sponge, because some of them have more organic material soils than others, and it's the organic material that can really hold water better, and particularly things like peatlands. Floodplains trap sediments, and the floodplains, when you have vegetation, it slows the water, it adds friction. Marsh vegetation, scrub, shrub, and trees are very important in slowing flood flows. And also when the flows are slowed, it allows more particulates to drop out. Another aspect to wetlands is that there have been studies that have shown that the more wetlands there are in a watershed, the greater the base flow in streams is during the drought. So if you have a drought situation, if you have more wetlands in the watershed, your streams may actually be better off in terms of not going completely dry. This diagram of the carbon cycle shows also carbon sequestration in freshwater wetlands, and how wetlands have the potential to sequester carbon for a long time unless the wetland is altered. So they perform a very important function in this regard. So for water quality, quantity, the data sources, map data, I mean, we're looking at land use again. You want to look at the topography and the position in the watershed. Definitely wetlands that have more of a basin shape are lower in the landscape. Isolated depression, actually even isolated depression up in higher in the landscape are very important for holding water that contribute to floods downstream. The vegetation type that's on the National Wetland Inventory maps is helpful. Gee, is it forested? Is it shrub? Is it aquatic bed? Have there been any hydrologic alterations from the mapping data? Any inlets and outlets shown? The soil type and the stream stats is where they provide the percentage of wetlands in the watershed. That is based upon 2001 national land cover data set data. So it's not recent data, but it's interesting information to that could be helpful. When you go out in the field, once again, confirming map data, looking at micro topography, because if you have a lot of pit and mound areas, they hold water. They can hold water longer. They can remove the particulates when the water is sitting or slowed. Things drop out more easily. Like I mentioned, the organic material in the soils is really important for holding water. And in the field, you can check for ditches and other hydrologic alterations that may not show up. So for wildlife, you're going to be looking for habitat for various types and populations of animals, typically associated with wetlands and the wetland edge, looking for areas that provide food sources, that provide water, that provide cover, provide breeding habitat. This covers both resident and migrating species. You can get species list, well, you can create a species list of observed animals. The Wildlife Action Plan, you can get some species list, particularly of the species of greatest conservation need. Wildlife looking at undisturbed wetland edge and buffers with adjacent wildlife habitat are very important, because like 2/3 of the wetland or more of the wetland dependent wildlife use uplands and wetlands. There's actually a great research document that was done in 2001 that's called Beyond Buffers, and it talks about wildlife use of buffers, and it was done in Massachusetts. Still a great resource. So when you're looking at wildlife, you also really need to be, if you're going out in the field, making sure that you look at things in the seasonal time frame, and if the applicant for a project has been out in the field, when have they been out in the field? Have they been out in the field, particularly with vernal pools at the time of year like now, versus going out in August and not seeing anything? This is a page from the vernal pool manual that Fish and Game put out, that shows some of the timeframes for the various stages of vernal pool. organisms. And then there's a wood frog and 2 vernal pools on the top right. One is in a utility corridor, and the bottom one is from, taken like in an August or September timeframe, when it was absolutely dry. So data sources for wildlife, land use, land cover, intact buffer, wetland size and type, the edge complexity, water regime. I'll talk about the vegetation interspersion, upland habitat. Is it connected to significant or rare habitat, streams and other water? So the rare habitat you might not find specifically mapped, but an applicant would have to get Natural Heritage Bureau, the data check information. And field data, that's really where a lot of it's an important part of the wildlife to be able to confirm the map data, look at the microtopography, vegetation structure, once again, organic material, seeps and springs and other open water, food sources, other animal signs. This has the photo is a beech tree with bear claw marks on it. Confirming vernal pools, and also confirming the invasive species presence or absence. Whoops. So I wanted to talk about the interspersion to give you an idea and of how that what that looks like. So this is a map of someplace, a National Wetland Inventory map from someplace in New Hampshire that has a lot of interspersion. Basically, you have 3 different classes of wetlands. You have the palustrine that begin with the P on the left, the lacustrine, which begin with the L, and the riverine, which begins with the R. And they're various degrees of wetness, whether they're seasonally flooded or permanently flooded, with some classes like the emergent. You have that one that means persistent vegetation. So that would mean something like a cattail versus some other vegetation that's not persistent, that dies back in the fall and is not, kind of disappears. With the forested communities, palustrine forested, the PFO, that one for forested community means that broadleaf deciduous. So this would give you an idea of what those are. But the interspersion, basically, there's a real mix here of the types, and you have different types next to each other. So you have palustrine aquatic bed, next to palustrine emergent, and next to palustrine forested. So this is a very diverse area. In terms of aquatic wildlife, looking at watershed characteristics, how well the watershed, is it forested or well vegetated? Once again, stream side, is there a buffer, and particularly buffer to provide shade? What are the barriers to aquatic organism passage? And the presence of woody material, because woody material provides much needed nutrients to stream habitats, particularly when they're forested or well shaded. And then is there diverse habitat within, like riffles and pools within the aquatic areas? So the data sources, once a land use adjacent to undisturbed upland or buffer, wetland position. If it's higher up in the watershed, you may have less fish, particularly, than lower down in the watershed. The aquatic restoration mapper provides information from the Wildlife Action Plan on the fishery layers. So it shows the eastern brook trout. And you can also get information on impaired waters. And while it's on the, I think the wetland permit planning tool, I'll provide a link to further information about impaired waters, where you could get the report card for the impaired waters. So for field data, you want to confirm the map data. Once again, the vegetation, the habitat, what does the stream or the aquatic resource look like, woody material present, and what's the extent of open water present. And all these, this information is going to go into evaluating, gee, what's going to be the impact of a project on functions and values. You know, the biggest impacts are really from habitat fragmentation. You eliminate migration corridors. There are barriers to migration corridors where they're not eliminated, and the loss of buffers have major impacts to wildlife and water quality. So that's where, you know, the need to avoid and minimize using that information comes in. So here are a couple, few additional resources. The NWI decoder is if you have a code off an NWI map and you don't know what it is, you can actually just type it in to the link and it will tell you what it is. So you don't have to, even there's a chart that you can check on, but that decoder works pretty well. This is how you get to the National Wildlife Action Plan, the habitat types and species. USGS stream stats, great to find out about the wetlands within the watershed. And then DES has a surface water quality assessment viewer, and that's where you can get more detailed information on impaired waters. And then I guess we'll hold questions to the end, but I will stop sharing right now.
We could probably take a few quick questions. I think we've had Marianne answered one of our questions in the chat, but if anybody has a question for Sandy, now's a good time to bring that up. If you want to put it in the chat or raise your hand, I can take a quick look.
Oh, I see. I will send, Barbara, I will send you the link to the document on buffers. That's a wildlife specific document on buffers.
Okay, that would be great. Yeah. And again, we'll be able to send these links as well in the follow-up email. So there's a question: for the entire series of the workshops, besides YouTube, will you be able to get the actual slides? Many have links to the websites. Yeah, I typically try to include those links to websites in that follow-up email, but we'll make sure that information is available as well. How do we test for heavy metals?
I think you'd need to contact a lab that does that. I guess you could probably start by checking with either the state lab, the New Hampshire State Lab, and see what they can in terms of, particularly, I don't know whether you're talking about testing like plants versus testing sediment versus testing water, you know, it would vary, and different labs have different capabilities.
Yeah. So the DES state labs, right? You're referring
or
to.
it's a Health and Human Services.
Health
So
and
I
Human
don't know
Services.
who
Okay.
It's one or the other, depending upon
Right.
what's being
What you
done.
want. Okay. All right. Great. Well, I think we can move on to Marianne at this point. Marianne's going to talk a little bit more about the data that you can get from mappers and how this might impact the property, as well as what we might be seeing at the our in-person field visit next month at the Lock Road property. And just a quick reminder, we did have a whole program on wetland mappers, and that again is on our YouTube channel if you want to review that for a lot more detail.
Okay, I'm ready. I can't get it to work by showing my face, so you're gonna have to be spared with seeing my lovely face. So
Okay.
something going wrong with my computer. So thank you all for participating in this training. It's been really great. And thank you to Barbara Richter, Rick Vanderpool, and Sandy Crystal. Those were great presentations, and for all the work they've been providing. We've had a lot of volunteers help out with this training as well. And I just wanted to provide a big shout out to them. I know Mark West, Mark Jacobs will be donating their time as well to help with the field training that we have coming up. So I wanted to just start out, this was my assignment, but I can't resist saying a couple things at the outset, just to reinforce what Rick and Sandy were saying, is that a wetland functional assessment really is the cornerstone of state and wetland federal permitting. So state and federal wetland permitting, understanding the functions and values of the wetland resources in terms of permitting is really fundamental. And so what we've been going through, Rick did a great job doing an overview of the different methods, and Sandy an introduction to how those are applied in the DES rules was very helpful. And I'm going to go through just one thing I want to point out to understand your role in commenting. The state doesn't technically have buffers except for in the prime wetland buffers where they're duly authorized, or in the seacoast where there's 100-foot buffer. So there may be other buffers at the town ordinance level, but at the state level, it has only those two areas. So I just wanted to clarify that as the DES role. One thing that was very beneficial when we just had March 10th and 17th, we had the Corps and EPA provide, DES hosted their training on the method that they're working on. And as part of that exercise, DES did go through a lot of the functional assessments that we received, the staff, the permitting staff did, and we did find some gaps. And so we will be updating some of our guidance based on that review. Some of the gaps I'll just throw out there for you to know, keep the lookout on. Some consultants are saying there's zero function in EPA, and the Corps said, no, that's not correct. There is some function in a wetland. So if you see zeros on a wetland functional assessment worksheet or table, you know that that's incorrect. And also they talked a lot about how you assess the entire functional assessment unit area, not just the area that's proposed for impact, but the connected system. And many folks are mixing condition with function. So those are things we'll be focusing. We've already posted those other videos from the federal training into our DES functional assessment worksheet. So I just wanted to give you some tips right out from the outset that we'll be working on. So what am I going to talk about today? Where do you find the mapping information online? And luckily, Sandy's already touched on a lot of that already, making my job a little easier. What are the goals and some mapping tools? So where do I look? What are the goals and the mapping tools? That's the agenda. So the first thing I would recommend is you look in as homework, actually, for those of you, I hope many of you are going to come to the Wetland Assessment Day in May here in Concord. But I would strongly recommend you all listen to Steph Tetrol, the Inland Wetland Supervisor's presentation she gave for this same training series on March 8th. I put a link to her YouTube video. I watched it and I learned tons of stuff. She went through and did live demonstrations of many of the tools and helped you look at all the details in terms of the different icons, setting the correct depth or resolution to making maps. And I highly recommend you looking at that. Steph actually developed the wetland permit planning tool. She's an expert on it, and she will do far better than I. And she looked at a lot of really cool tools, and I thought it was very interesting. So I strongly recommend you check out this video. And here's a link to the planning tool as well. And I recommend that you check it out. If you haven't yet, just play around. Go in, accept the acknowledge that it's limited in terms of its resolution. It's just course screening and planning, but also go into the tool. You can put in an address. You can go down to the left, click some layers, just try it out. You can go up on some of the tools, click identify, and it will help you out. I've generated many maps. You can do free maps for USGS on it and find your own property, something that you're familiar with, just to get oriented. There's lots of cool things in there. There's also the aquatic restoration mapper. Steph did a brilliant presentation on that, going through a series of stream crossings on the mapper. There's lots of valuable scoring information. The fish mapper is linked in there from Fish and Game, where you'll see documented fisheries. You'll see black flags showing where we've documented local flooding. There's a conservation land layer in there. So it's really a great place for towns to look, especially if they're thinking about applying for ARM fund grants. So the goals are really, to get started, is I want you to think about what Rick and Sandy have said and what you know, and think about the landscape context. So if you look at the wetland functional assessment form that I think Sandy pulled up from the highway core method, it's this long form, lists all those different functions. Right on the top, there's a thing that talks about where is your site? What's the background? What's the land use? What's the context of this site? That's really critical. And if you look at the highway method, I'm looking on page 3 of the supplement, it says the proximity of development may alter wetland functions and values. Therefore, evaluation of the resource must consider not only the wetlands, but also adjacent land use and associated interrelationships. So all the discussion that Sandy had about condition and context, and that Rick brought up as well. So that's a critical first step. You want to look at how can you identify known resource areas? Are there habitat areas, fishery areas, wetlands, stream systems, and then of course the jurisdictional areas that DES regulates through wetland permitting. Are there areas where these systems are connected? Are they part of one system in terms of wetlands and streams? And as you've already just heard from Sandy about NWI, what is NWI? National Wetland Inventory. So that's where we did statewide mapping. It was published on US Fish and Wildlife Service website, and it has these classification types, what Sandy was saying about the PEM, and that's just a fancy way of saying a marsh. So these are all different terms and things that we'll get into a little more. And then review the aerials to understand the resources and the history. So there's lots of interesting information, probably more information. So it's really key to focus on what is the most important thing to get started. So I've included some slides here that go to the site where we're going to have the field assessment day, just to help you get oriented. You'll see a repetition of the same resources, but I invite you to do something in your town where you're familiar with and look at the aerials. So this is an aerial imagery. You can see the date here. It's at Lock Road in Concord, where we're going to have our field assessment day. You can see Lock Road, and you can see this dirt road in yellow running through, extending to the Merrimack River. So you can see some really obvious features. And many of you may have familiarity at looking aerials, and some may not. So the more you do it, the better you get, just like anything, right? And so all these little yellow things, those are just parcel mosaics. Those were developed for ambulances for 911. A lot of them are similar to town tax maps, where the properties are. So you can see there's some development here near the site. You can see all this lawned area. It's probably agriculture, right? And then you can see these little bubbly, woody, forested areas, right? So you can see some island, you can see different things that are going on, right? You can get sort of a scope and scale. And so this is a good thing to practice looking at. You can learn a lot from an aerial. So I invite you to look at it. It will be better to look at it live because you'll have better resolution, right? This is just a clip that I took for the slide. And this is LiDAR. So this was something that the state purchased after the massive floods we had in Alstead. The Flood Study Commission and the assistant commissioner, who was an engineer at the time, realized the value of this for New Hampshire. So this will allow you to really have, you'll see this is LiDAR, bare earth, hillshade. So you can see, you can visually see the topography changes. We have the river again, right? And we have that dirt road will be coming down for the training. We have Lock Road, and you can see some of the changes, right? Maybe there was an area where the river may have jumped over. right? You can see topographic changes. And even the state has a stone wall mapper based on this LiDAR. So this is really, really valuable. You can look and see different drainages. You can visualize what's going on in the landscape. So this is a really cool feature, and we're really lucky to have it. A lot of the other states don't have this. This is FEMA, the floodplain maps. So when we're looking at wetland function, one of the key things we've already heard about is flood storage function. And a lot of times you'll have these floodplains, right? This is in the FEMA floodplain. It has all these different notations here, you know, whether something's in the floodway, see that fancy stripe there, and you got that right along here along the river, that's the floodway. And you have different index and all different terms. We also have the wetland types shown on here. That's from the NWI that Sandy talked about, and they all color coded, right? Like she already mentioned, you know, whether there's freshwater pond. Here we have riverine, obviously, because we have the Merrimack River. And then we have bright pink estuarine and marine. Is that correct? Probably not, right? Because we're not in the seacoast. So I think that you do have forested scrub shrub wetland. That's a key thing to look at, right? And I think I'm reading that wrong. That's freshwater. Emergent wetland, and then freshwater forested scrub shrub. So you have those funny different colors, the pink and the purple, and then you have the orange. This is basically a key thing here is to know, okay, you're in the floodplain, you're on the Merrimack River, and there might be a flood storage function, right? And so those are important functions in terms of protecting private property. And I suggest that you look at EPA has a fact sheet series on the economic benefits of wetlands, and they talk about the benefits to preventing property damage. So landscape context, talking some more. Here's another tool that you can look at, the Web Soil Survey. And this shows the generalized core screening maps. You know, it doesn't have none of this has the site detail. This just has what they did based on them going out and looking at a few hundred sites, you know, over a year. So they didn't have a lot of time to do detailed digging. But these maps are helpful. They have all detailed descriptions on them and give you some idea of the history or the type of soil. And this is the one for this site. And this again is the dirt road will be going on. This is the development, and here's the Merrimack River. So you can look at that. You can actually click on to that link right here. And I invite you to look at your own property, and you can draw little areas and maps right from that website. It's really great. Here's one that has poorly and very poorly drained. So the poorly and very poorly drained are generally considered hydric and sometimes somewhat poorly drained. But when you got very poorly drained soils, those are the wettest of the soil. So you can see the darker areas that extend across these coarse maps. And these are what they call drainage maps, soil drainage maps. And then again, we have the river on the left. And this is just a generalized depiction of soils for this site. So as we've already heard, the 3 parameters for wetlands, right? We have soils, hydrology, and vegetation. So that's another thing that can give you a guide. And so these are all what EPA calls level 1. So these are desktop tools just for core screening. And then we have the imagery with NWI, which we've already shown on a different screen. And this has all the different classes, which is important to understand because you know if there had been documented shrub, open water, emergent, or forested areas. And as Sandy said, that interspersion is so important in understanding the function of the resource. In here, we even have some along the river. See the Merrimack River? And you have some wetlands shown along the Merrimack River. And here we have wildlife habitat land cover. And so this comes from New Hampshire Fish and Game, and this is part of their mapping of different communities, like ecological communities. So this is a different type of mapping from NWI. So all these things you can pull together and compare. And here we have the Merrimack River, Lock Road, and the trail we'll be going on. And here are prioritized habitat blocks, and you can see it runs through this system. And someone might say this is a corridor, right? If you have a wildlife habitat corridor, we did see lots of wildlife at the site, and we did see them actively moving through the site. So it's quite exciting. We saw even spotted turtles. We saw deer and birds, and just in our few days where we've been scoping out the site. So there's lots of interesting things to see at this assessment site. And here is the wildlife action plan. And this is modeled data with embedded documented threatened and endangered species. So you can see along the river, that's the pink, the highest rank habitat in New Hampshire. So that's right near this site. And then we have the second is this bright green. So this gives us clues that the modeling of the scientific data that Fish and Game has shows some high value areas. And we did document species at the site as well. So again, I recommend you look at the wetland planning tool. I've given a link here again. And some of the updates we've just made based on meeting with the wetland science team include highlighting the aerial imagery, moving the LiDAR into the base map, and the new NWI plus, which was only finished updating in 2021. So it's good. And then we also have wildlife corridors. So we have, if there's riparian corridors that link through your site, you'll be able to see those on the wetland planning tool now. So this is just to show, we did upload the National Wetland Inventory map information on U.S. Fish and Wildlife Service. And this is where it is originally housed, but we pull all that data onto our mappers, since they're the ones that verified the extent and classification based on the federal mapping standard. In the ARM mapper, this is just a clip from some of the different scoring metrics you'll see in these located stream crossings. But this is one that I highly recommend you look at through Steph's presentation, everything from aquatic organism passage, whether it's compatible to that site, to hydrologic vulnerability. UNH has developed scoring methods to see if there's overtopping and what the status of those crossings are. So I just want to mention that I think that it's going to be really important for you to try to do some level 1 desktop analysis on your own. You can see this is a key thing in starting your understanding of wetland functional assessment. As Rick said, he went through 3 or 4 methods. There's a lot to it. And I do think that the more you look at it, the more you can understand it. Understand where you can see the standing water, the hydrology, where there might be hydric soils, looking at the vegetation, what the resources are, and how they're all connected. One of the key things is understanding if there's an impact, if it's going to impact or de-water downstream wetlands or resources, or have impacts to adjacent connected systems. There is a connectivity standard in the rules as well, so that ties in well to looking at functions and values. I do recommend, if you have more interest in this, that you check out, there's a state of Connecticut DEP video series on wetland function. And New Hampshire Fish and Game does have a habitat series, which includes floodplains, marsh shrub, and vernal pools. And there's a lot of valuable information out there, and I'm happy to answer any questions.
Excellent. Thank you so much, Marianne. That was really a great example of what we'll be seeing in the field coming up in May. And again, yeah, I would really recommend, before you go out to a site, do as much preliminary investigation as you can, so that you get a good feel for what's out there, what to look for, and some of those wetland impacts you might be facing if there's going to be a wetland disturbance. So, as we mentioned, this is kind of the prep for our field study class. And the field study, again, it's going to be on May 19th from 1 to 4 at Lock Road in Concord, and that's just north of the city. And I'll be sending out all this information prior to the day, so don't worry about it. You don't have to remember it all today. And the great thing about this site, as you could assume from the maps that Marianne showed us, is that there's multiple wetland types out there. There's also examples of various disturbances and impacts. So you'll get a good feel for a wide variety of impacts and wetland types. So in addition to the great site, we also have some excellent presenters. And again, I can't thank everybody enough for the work they've done on this series. We'll also have Marianne Tilton back with us, Sandy Crystal and Rick Vanderpool, but we'll have Mark West and Mark Jacobs as well. And a few more DES staff people will be attending to help us in this program. And we'll have, we're going to have different sites and different stations to rotate through to really be able to view those different wetlands that are out there. I will again be sending the link to this program, link to the recording to this program, as well as many of the links that were mentioned in the program today. And we'll be happy to follow up with any additional questions you have. We didn't have too much going on in the chat box, but if anybody does have a final question, I think we can open that up to all three presenters. And for the last few minutes, if anybody has a question for Mary Ann, Sandy, or Rick. We might just have overloaded everybody, which is fine, but we did want to cover again. I think that's part of the reason why we wanted to break this up. So let's see, we do have a few questions. How often do these maps how often are the maps updated?
It depends. How's that? That's my short answer.
Yeah, I guess it depends on which, yeah.
I mean, aerials we used to update every 10 years, and then it was 15, and it's changed. LiDAR hopefully will, that's the base elevation LiDAR was shot in 2018. That probably won't be updated for a while. Marianne, I don't know if you want to weigh in on this, but or Sandy, but it really depends on what resource you're looking at. The best, which is what Marianne queued up to, was all the links to the online maps that Stephanie reviewed, and especially the DES base, the aquatic resource mitigation, and the wetland planning tool, permanent planning tool. Those are updated almost daily, right? So you'll get new data coming into those online maps relative to actual projects, sites, and that kind of information. But when it's large remote databases like NWI Plus or that kind of thing, those take several years to update.
Yeah, the excuse me, the NWI were just really recently updated for the state after coming out in the 1990s.
80s even.
Something like that. So yeah. Some of those things don't get updated that often. LiDAR, I think they were redoing some of it because the earlier LiDAR that they did was not as good a resolution or what have you. So they were redoing it. Oftentimes there's more data for the coast because there's more coastal zone funds that fund the gathering of of data for flooding, for sea level rise or what have you. So it like Rick said, it depends upon the purpose of the data as to how frequently it may get updated. I know for the Merrimack River watershed, there are new flood maps that are in draft. And so I know from that perspective, there will be some new stuff coming out. I don't know whether it be about another year or so before it comes out.
Yeah, and that's, part of the reason why it's important to visit the site to really kind of ground truth that information that you're seeing in those maps and to clarify kind of where those boundaries are and really get the on the ground information so it's more accurate. All right, so Marianne's definitely sending us a lot of links, which I'll make sure I'll get into our follow-up. But I, again, want to thank everybody for joining us. We look forward to seeing you all on May 19th. And again, in the meantime, feel free to email me if you have any questions, and we can also reach out to our presenters as well if you have additional questions for them. So everybody have a lovely afternoon. Try to stay cool out there. It's pretty warm, and we'll be seeing you soon. Thanks so much.
Take care.
Thank you. Bye.